Hi everyone. In this tutorial, we will create an Oracle 12c physical standby database. This tutorial aims at creating a single instance with ASM Oracle 12c physical standby database. I am expecting the person who wants to implement this tutorial to have basic knowledge on Oracle database administration. If you don't know about Oracle Database Administration, then this tutorial is not for you. It would be better if you know about the concepts of the Oracle Data Guard, because if you do, you will understand the concept of all the steps that we're gonna do in this tutorial. However, this isn't mandatory. If you don't know about the Oracle Data Guard and you follow the steps in this tutorial, you will still be able to create and enable the physical standby database. But perhaps you will not understand the concept behind some of the steps in the tutorial. To perform this tutorial, you need Oracle VirtualBox version 5. Oracle VirtualBox Appliance that has Oracle 12c single instance database installed in it. If you don't have such an appliance, create one using the tutorials in my YouTube channel. I will add a link on this slide to that tutorial. You cannot do this tutorial without having this appliance. You also need the tutorial document. This document is the guide that I used to implement this tutorial. You can download the document from my website as shown in the slide. When you implement this tutorial yourself, and if everything goes well with you, I think it will take you a couple of hours to finish. If you know about the Oracle Data Guard, you can skip this slide. But for those who doesn't know about it, let me give you a brief of how Oracle Data Guard can be useful in real life. When you configure Oracle Data Guard, you go to the production database and make another database out of it. This copy of the database or this replica of the database is called standby database. This standby database can be used in the following scenarios. First, it can be used for Oracle Database Disaster Recovery. In this scenario, you create your standby database in a remote site. If the production site has any disaster, any natural disaster like an earthquake, a flood, fire, anything like that, you will use the remote site to recover. Also, you can use the data guard for server high availability, which means if anything goes wrong in the production server, you can use the standby database for recovery. Also, Data Guard is useful for offloading read-only queries, which means you run the reporting tools on the standby database. Reporting tools usually takes a lot of resources from the server, so instead of running it on the production database, you run it on the standby database. Also, you can use it for offloading the backup. Again, backup operations usually take a lot of resources from the server, so instead of running it on the production server, you run it on the standby database. Those two advantages are good for utilizing your production server resources. Another very nice feature of Data Guard is rolling upgrade. Upgrading Oracle database usually involves very long downtime. Using this nice feature, which is rolling upgrade, you can reduce the upgrade downtime from hours to a few seconds. Data Guard is also very useful for performing testing. If you want to make any changes on a production system, sometimes it could be very risky. Instead of taking the risk of implementing the changes straight away on the production, you can perform the test on the standby database, evaluate the effect of that changes on the standby database. You take the decision to go ahead with the changes of the production server or not. This is just a high-level description of the advantages of using Data Guard in real life. There are two types of standby databases: physical standby database and logical standby database. Talking about the differences between them is beyond the scope of this tutorial, but I have to mention this fact because for those who don't know about Oracle Data Guard, they need to know that we are here building up a physical standby database, not a logical standby database. Enough talking about concepts, let's get started with the tutorial. As I said, this tutorial describes the procedure to create a physical standby database. We're going to use Oracle Database version 12.102 running on Oracle Linux 6.7 64-bit. To implement this tutorial, you need PuTTY software and you need Oracle VirtualBox version 5. This tutorial also needs an Oracle Appliance which has Oracle Database single instance installed in it. You can follow the tutorial in my YouTube channel to create one. Appliances created by this tutorial will take about 42 GB of disk space. This diagram describes the specifications of the database that I am working on. This diagram describes the specifications of the database we are working on in this tutorial. The database name is OraDB, and it is connected to an ASM instance. The ASM instance has 3 disks named CRS, Data, and FRA. The host name of the primary database is called SRV1, and the operating system is Oracle Linux 6.7. If the IP address assigned to the appliance that you download from my website doesn't go compatible with your network, you can either change the settings of your virtual network adapter so that it becomes of the same subnet as of the appliances, or you can change the network settings of the appliance. I would recommend changing the settings of your virtual network adapter because this will take much less time than changing the network settings in your appliance. This table lists the specifications of the data guard that we're going to create. We're going to create a physical standby database. The protection mode will be maximum performance. The fast start failover will be disabled, and we're going to use SQL Plus as a utility to manage our data guard. The standby database name will be OraDB_S2, and the host name of the standby system is called SRV2. This is an overview of the procedure we're going to implement. First, we're going to clone the Oracle Database Appliance twice. One will work as a primary database and the other one will be a standby database. We will make some configuration changes on the standby appliance to make it ready for the practice. You may think, do I really need to make a clone of the primary database? Actually, this is not necessary. If you have another appliance with the same Linux operating system, and you install Oracle software in it, you can use it straight away. In real life, you have another server with the same Linux version and the same Oracle software version installed in it. In the second phase of this tutorial, we're going to prepare the primary database. You will first enable the archiving mode, configure archive log deletion policy in RMAN, enable force logging, configure standby redo log files or SRL, set the related primary database initialization parameters, enable flashback database, set control file record keep time parameter, create a password file, configure the tnsnames.ora file. You also need to prepare the standby system. For that, you have to create the required directories, create a static listener entry for the standby database, create an init sid.ora file, copy the password file from the primary system, configure the tnsnames.ora file. All those steps should be done to prepare the standby database. After that, you go ahead and create the physical standby database. For that, you do the following. Use RMAN to create the physical standby online from the primary database. Actually, you can also use RMAN to create a physical standby database from a copy of the database backup files. But I prefer to use the online option because it doesn't need very large disk space. After that, you set the standby database parameters, start the redo apply service, verify that the physical standby database is performing properly, and finally you will do some post-creation steps. It's time to start the practical stuff now. As I said, we will start by preparing the practice environment. First, make a clone of your Oracle 12c database appliance. When you clone your appliance, do not initialize the network card. This clone will be used as the primary database. Give that cloned appliance the name PrimaryDB. So this is the appliance which has Oracle database installed in it. I'm gonna clone it twice. The first time I'm not going to initialize the network card. It will take some time to finish. Make another clone of the appliance. Make sure this time that you initialize the network card. Give that cloned appliance the name Physical Standby DB. As I said, you have to make sure that this checkbox is marked. So we've got now two appliances. One will be the primary database and the second one will be the physical standby database. At the moment, they are copy of each other. We need to drop the database from the physical standby database and make it ready for our tutorial. Because we initialized the MAC address of the second appliance, we need to fix the MAC address issue in it. Follow the steps as shown in the document to fix the MAC address in that appliance. You need to open that file and fix the MAC address in it. You need to get rid of the section underneath and fix the MAC address in the upper section. As shown in the document, you also need to fix the MAC address in this file. So, as I said in the second phase of this tutorial, you have to prepare the primary database. First, you have to enable the archiving mode in the primary database if it is not already enabled. As you see, in my case, the database is not running in the archive mode, and I have to enable it. Forced logging must be enabled in the database. Configure the standby redo log files. Standby redo log files actually are not used in the primary database, but they will be used by the database after you switch over or fail over. For a single instance database, their number must be the same as the online redo log file plus 1. In my case, I have 3 online redo log files and a single instance, so I need to configure 4 standby redo log files. By the way, when you copy-paste into PuTTY window, if you copy more than one command, you have to press the Enter button multiple times, depending on the number of the commands that you pasted. In my case, I have 4 commands, so I had to press the Enter button 4 times. As you can see, 4 standby redo log files have been configured. For a primary database in DataGuard, you must configure some initialization parameters. You must configure DB unique name, and you must configure log archive config. DB unique name is the unique name of your instance. Because this is the primary database, usually you don't change it. For the log archive config, this is very important parameter. With this parameter, you specify all the databases involved in your DataGuard configuration. In my case, I have 2 databases, so I set that parameter to 2 values, OraDB, which is the name of the primary database, and OraDB is2, which is the name of the standby database. The log archive destination 2 is the most important parameter actually in our case, because this parameter is telling the primary database all the information that it needs to communicate with the standby database. So in my case, I'm telling the primary database that it has to connect to OraDB is2 as the standby database, and it must use the asynchronous redo transport service method. The valid for attribute is telling the database that it must transport the redo log files to the standby database only if the current database is the primary database. Finally, it tells the primary database that the DB unique name of the standby database is Oracle DBS2. So let's set those parameters now. Another parameter you can set is archive lag target. With this parameter, you force the primary database to switch the log file after a specific time of inactivity. This is actually an old habit, but it's optional. It's up to you. You can configure it or you can skip it. Another parameter you must consider is the remote login password file. This parameter must be set to exclusive. Also, the file server parameter should be set. You have to set it to the unique name of the standby database. The parameter db file name convert must be considered if the directory structure of the standby database is different from the directory structure in the primary database. In my case, I don't have this issue. The directory structure is the same, so I don't have to set this parameter. The standby file management parameter, it is highly recommended to set it to auto. Let's execute those commands and the command line, and I will talk about the rest of the parameters after that. You need to get list of the directory dependent parameters so that you create the same directories in the standby database system. You need to take note of those directories so that you create them in the standby database server system. It is highly recommended to enable the flashback database option. Your life as a DBA will be much easier to manage your data guard configuration if the flashback database is enabled in the primary database and the standby database. Because the records of the archived redo-log files are saved in the control file, I would recommend you to increase the value of the control file record keep time from the default value, which is 7 days, to a higher value. In my case, I increased it to 30 days. If your database is running without a password file, you must create one. This is mandatory for creating a physical standby database. In my case, I already have a password file, so I don't have to worry about it. This is just the full file name of the password file used by the primary database. You need to configure the tnsnames.ora file in the primary database so that it can communicate with the standby database. If you are using the PDF file that I am sharing in my website to implement this tutorial, I would recommend you in this step not to copy-paste the code from the PDF file. For some reason, you will face some issues if you copy-paste from the PDF file into the tnsnames.ora file. I would recommend to either copy-paste from the PuTTY window itself, as I'm going to show you soon, or you enter the settings manually. As you can see, in my case, I am copying from the PuTTY window itself and pasting into the same window, and then manually changing the configuration. I have to change the descriptor name and the host name and the service name. The setting UR equal to A should be set for the descriptor you use to configure the standby database. This is recommended by Oracle. If the SQLnet.ora file is not configured, it is recommended to create one. Let's test the configuration now. In this step, I am fixing an issue that I observed when you use the duplicate target database to create the standby database in RMAN. For some reason, that command will look for the SP file under the data disk group in a location or a directory different from the actual location of the SP file. And the only workaround that I figured out to fix this issue is to make a copy of the SP file to the directory where the RMAN is thinking the SP file is in it. So, using the command show parameter SP file, I can know which SP file the database is actually using. Now I will switch to the grid user and make a copy of that SP file to the directory data disk group -oradb. Because I'm making a copy to a disk group, I will use the ASM CMD utility to copy the SP file to that disk group. Please observe the format of the SP file that we copied. It is SP file followed by the SID of your primary database .ora. We have reached to the third phase of our tutorial, where we have to prepare the standby database system. In the first step, we have to create the directories pointed by the parameters in the database. Remember, when you want to create the directories in the ASM disk group, you have to switch to grid user. The file system directories they must be created as Oracle user. In the second step, we will create a B file, and in that file, we put just single parameter, which is db_name. We assign the database name to that parameter, not the database unique name of the standby database. We have to assign the name of the database, which is in our case OraDB. The password of the sys user must be the same in both databases. This is mandatory for the physical standby database to operate properly. In my case, instead of creating a password file from scratch in the standby database system, I will just copy the password file from the primary database system to the standby database system. Of course, the password file in the standby database system should be renamed, because it should have the format OraPW followed by the SID of the standby database. In the fourth step, I have to configure the tnsnames.ora file, and again, instead of configuring the file from scratch, I will make a copy of that file from the primary database to the standby database. First, I will take a backup of the current tnsnames file in the standby database. After that, I will make a copy of it from the primary database. If the SQLnet.ora file is not configured, create one. In the fifth step, we're gonna create a static database registry in the listener. This should be done as a grid user. Although the documentation claims the automatic registration should work fine, actually, I have faced many issues with the dynamic registration. From my experience, it is safer to register the database manually in the listener. And again, when you configure the listener.ora file, don't copy and paste from the PDF file. I have put the script code in a notepad file so that I can copy from it and paste in the PuTTY window. Remember, you need to do that as a grid. Open the listener.ora file. And enter the static registration of the database. To make the listener take effect of these changes, I have to restart the listener. So far, we have done everything needed to prepare the primary database and the standby database. We are ready now to do the most important action in our tutorial, which is creating the standby database. First, I have to start up the standby instance using the code as shown in the document. Now I am ready to create the standby database online from the primary database. For doing that, I'm going to start RMAN and connect to the primary database as target and to the standby database as auxiliary instance. You use the command duplicate target database for standby from active database to create the standby database online from the primary database. When you do that, the instance will be created and everything will be done in the background by the RMAN, and you have also the option to change the value of any initialization parameter within the command itself. In my case, I changed the DB unique name, the control files location, the default destination of the data files, and the location of the multiplexed online RAC files, the FRA disk group, and the data disk group, the DB recovery file destination, the DB recovery file destination size, the audit file destination, and the core dump destination directory. All of those parameters have been set within the command itself. If this command runs successfully, the standby database instance will be up and running. So the command has finished successfully and the standby database instance is up and running. Let's verify that the instance is running fine. I will connect to the SQL Plus. I'm listing here the data files in the standby database. As you can see, they are all located in the data disk group. I'm listing here the standby RAC groups. We've got 4 standby RAC groups. Those standby RAC files will be used by the standby database. Here I'm listing the standby RAC files. As you can see from the output of this select query, we've got 8 standby RAC files. Those RAC files are 8 because Oracle by default will create multiplexed standby RAC files. Actually, we don't need to have multiplexed standby RAC files, so we will delete the multiplexed standby RAC files and keep only 1 copy of those files. So in this step, I'm going to remove the multiplexed copy of each SRL. SRL stands for standby RAC. I'm going to remove the multiplexed copy of each SRL group on the standby database. As you can see, some of the files are saved in the FRA disk group, and some of the files are saved in the data disk group. I'm going to delete all the files that are saved in one of the disk groups and keep the files that are saved or located in the other disk group. My target here is to delete all the SRL files that are located in the data disk group. When you receive this error, this is because the current SRL file is being used. At the moment, you can skip removing this file and remove the remaining files. We will take care of removing this file later. So far I have deleted 3 files, and I have now to take care of deleting the one which caused the error, the last SRL file located in the data disk group. Our plan is to log into the primary database, switch the log file, and then try removing that file in the standby database. I have to log in to the primary database and switch the log file. Go back to the standby database and try to drop the file again. Here you go, the file has been dropped. Let's verify how many SRL files we've got at the moment. We have 4 SRL files, all of them located in the FRA disk group. In this step, you have to set the necessary DataGuard related initialization parameter for the standby database. They are actually the same parameters that we have set in the primary database, but we need to set them differently for the standby database. The most important parameter is the log archive destination 2. This parameter is telling the standby database which database it should connect to when it becomes the primary database. Now we are ready to start the apply process. Once started, the synchronization between the primary database and the standby database will start. With this step, actually, the DataGuard configuration is finished. We have the 2 databases up and running, and they are in sync. Let's verify the DataGuard configuration now. First, I will check the sequence number of the redo log received by the standby database. In my case, the standby database has reached to sequence number 17. Now, on the primary database side, I will switch the log file. Now I will check the sequence number on the standby database side. As you can see, the sequence number has been incremented in the standby database and reached to the number 18. You can have a look at the processes running in the standby database side. As you can see, we've got an RFS process which is running in the standby database. This process is actually communicating with the primary database to receive the redo log files. And also we've got the MRP process, which is used in the standby database side to apply the redo received from the primary database. Let's do some post creation steps. Those are some recommended steps that you usually do after creating a standby database. First, we need to configure the archive deletion policy. You need to configure the archive log deletion policy in RMAN in both systems. If you don't do that, the archived redo log files will keep accumulating in both systems and eventually it will make the disk full. When this policy is active, any archived redo log file will be marked as obsolete if it is transported to all the standby databases and applied on those databases. You need also to fix the Oracle SID variable in the standby database system. So I opened the profile of the Oracle user and set the Oracle SID environment variable. I would also set the Oracle unique name environment variable, but actually this parameter is used by the enterprise manager, not by the database. So even if you don't set it, it won't at the moment affect our configuration. The standby database created by the RMAN will not have the flashback database enabled, although the primary database has the flashback database enabled, but the standby database is not. We need to enable the flashback database in the standby database as well. If you want to enable the flashback database in the standby database, you have to stop the apply process first. And what this command is doing. Alter database recover managed standby database cancel is actually stopping the apply process. You need to stop it first, enable the flashback database, and then start it again. The last step in our post-creation steps is registering the standby database in the Oracle Restart. Oracle Restart will take care of starting the database automatically when you reboot the system. That's why I would highly recommend configuring the database in the Oracle Restart. Please observe the command that we used to configure the database in the Oracle Restart. We have set the start option to mount, which means the database by default will start in the mount state. This is usually the case in physical standby database. You can open it in the open state, and in this case actually the client will be able to run read-only operations only. Even when you open the database for read-only operation, you cannot start the apply process in the physical standby database unless you have a license for that. And that license is called Oracle Active Data Guard. You need to make sure that you don't run the apply process while the database is opened in the open state unless you have that license. So we have configured the standby database in the Oracle Restart and started the database using srvctl utility. As I have just said, the database is running in the mount state by default, and if you want to open it for read-only operation, you have to stop the apply process unless you have the Active Data Guard license. The procedure to shut down the configuration is easy. First, you stop the standby database and stop the primary database, and finally shut down the appliances. Now, I will demonstrate to you how to shut down the whole data guard configuration. First, you stop the standby database. Then, as root, you shut down the system. And you do the same in the primary database. You shut down the database and then shut down the system. Bear in mind that every time you start the standby database, you need to start the apply process. You use the command alter database recover managed standby database disconnect to start the apply process. And that's it for this tutorial. We have learned how to create a physical standby database online from a primary database. If you want a copy of the appliances that I have created in this tutorial, please drop me a line. I will try to make them available for you on a public FTP server. I hope you find this tutorial useful for you to create your standby database. If you have any comment or question, please don't hesitate to contact me. If you need to have more information about DataGuard, you can attend my Oracle DataGuard course in Udemy. Thanks for staying with me. Till seeing you in the next time. Have a nice day.